Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the graph of prime of f at x to sketch the graph of f at x. So as per the problem, the following graph represents the derivative function prime of f at x of a function f at x. Determine the intervals where f at x is increasing, the intervals where f at x is decreasing, and x coordinates for all local extrema of f at x. Assuming f at 0 equals 2, make a rough sketch of graph of f at x. So we'll have to analyze the graph of prime of f at x. So as you can see in this graph, it is a straight line and has the x-intercept at x equals 2. Now on the left side of this x-intercept, the graph is below the x-axis. So as a result, the prime of f at x is less than 0 on the left side of this x-intercept because the graph is below the x-axis. Now on the right side of this x-intercept, the graph is above the x-axis. So that means the prime of f at x is greater than 0 for all x values to the right side of 2, and for the left side of 2, so for all x values, the prime of f at x is less than 0. So we can use this information to write the increasing and decreasing intervals for function f at x. So let's start with the increasing interval. So in this case, the function is increasing over an interval when prime of f at x is greater than 0. So in this case, it will be all x values to the right side of 2. So we can write that in interval notation as 2, infinity. So all x values greater than 2. So in inequality notation, we can write that as x is greater than 2. So there is only one interval over which the function is increasing. So now we can write the decreasing interval. So the interval over which the function is decreasing is the one over which prime of f at x is less than 0. So in this case, all x values below 0 or less than 0. So in this case, the interval in interval notation is negative infinity to 2. And in inequality notation, we can write it as x is less than 2. And for this graph, there is only one interval over which the function is decreasing. So now we have to find the x coordinates for all local extrema of f at x. As we can see in this graph of prime of f at x, as we go from left to right, so on the left side of 2 of the x equals 2, the function is decreasing, and as we go from left to right, as the graph crosses x equals 2, then it becomes an increasing function. So therefore there is a transition as we go from left to right, from decreasing to increasing. So that means there is a local minimum at x equals 2. So this is a very important concept you need to understand and memorize about analyzing graphs of prime of f at x. Now we can use this information to sketch f at x. So for that, we'll use the given point. So we are given that f at 0 equals 2. So one point that lies on the function f at x is 0, 2. So we can plot that on the grid. So it's the y-intercept of f at x. Now we have identified that there is a local minimum at x equals 2, and to the left side of 2 the function is decreasing and to the right side it's increasing. Now we are not given the y coordinate for f at x equals 2, so we can show the local minimum at any point for which the x coordinate is 2. It can be above or below the x-axis, but it should be identified in a way that we are able to show that the function f at x is decreasing on the left side of 2 and increasing on the right side of 2. So our point should be below this y-intercept. So we can show the point here as the point where the local minimum is, and on the left side we can extend the graph like this and then passing through the y-intercept. And on the right side we can show the graph going up like this. So we can see that as we go from left to right towards x equals 2, the function is decreasing because any tangent we draw to this function will have a negative slope. And to the right side of 2, the function is increasing because any tangent we draw to this graph will have a positive slope. So this should be the sketch f at x. So this is one possible sketch of f at x. There are many possible ways in which you can sketch f at x based on the given information. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to analyze the graph of prime of f at x very carefully in order to identify the increasing and the decreasing intervals and any local extrema, and then use all of that information to sketch f at x. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.